machining. Second one is classification of manufacturing process, comparison between conventional and non-conventional machining process, classification of NTM, need of non-traditional machining process, working principle of abrasive jet machining process, and last but not least, process parameter affecting MRR in abrasive jet machining. So, first initially we have to understand what do you mean by manufacturing process. Manufacturing process deals with conversion of raw material into finished product according to its particular dimension, shape and size. Let us consider this is my workpiece, which is a raw material which is made up of mild steel, and after doing lot of operation onto that particular workpiece, I can prepare a finished product like that. Are you observing, students? This is my finished product and this is my workpiece. By using machining process, I can convert this raw material into finished product. Now, I have to classify the conventional machining process based upon the different energy domain. Conventional machining process are of various types. Conventional machining process, take an example, maybe the lathe machine, maybe your milling machine, maybe grinding machine, all are related to a conventional machining process where the energy domain is only the mechanical energy. Basing upon that, the manufacturing process is divided into two categories. One is primary manufacturing process, second one is secondary manufacturing process. In primary manufacturing process, we are only giving a basic shape and size to any of the component. And second one is secondary manufacturing process, where we are giving a desired shape and size to the final object or final product. Now, again, according to the metal removal process, again the manufacturing process is of two types basing upon metal removal rate. One is conventional machining process, second one is non-traditional machining process. In conventional machining process, as we have already discussed, that is conversion of a raw material into finished product by using a physical tool which is known as a cutting tool. By using that, we can remove the excess material from a given workpiece and we can convert it into a final product. But in case of your non-traditional machining process, we are using various energy domain where I can convert the raw material into a finished product by doing different operation where the metal removal process can be conducted. Then we will discuss what are the various characteristics feature of a conventional and a non-conventional machining process. First one, in conventional machining process, generally microscopic chip formation takes place. Then again, what do we mean by chip? When we are removing excess material from a given workpiece, that will be converted into some waste material which is in terms of chip. As we have already discussed in the previous classes, chips are of various types. One is continuous chip, discontinuous chip and built of edge chip. Second point, metal removal takes place due to application of cutting force. Energy domain can be classified as mechanical only in case of your conventional machining process. Third one is, when we are going to cutting the raw material into the finished product, the major characteristics feature should have the cutting tool must be harder than the given workpiece. If it is not harder, then the metal removal cannot be possible in case of your conventional machining process. Then we will discuss what are the various characteristics feature of a non-conventional machining process. In non-conventional machining process, there should be a chip formation will take place, either no chip formation will take place. Take an example. For example, in SAM process, the chip are very microscopic size, but in case of electrochemical machining, there is no chip formation because there is metal removal takes place due to electrochemical dissolution. Then second topic we will discuss why we require non-conventional machining process or why non-traditional machining process if there is a conventional machining process exists. So the first point is, in case of your non-traditional machining process, there should not be a physical tool is present. As there is no physical tool is present, so there will no tool wear. So we cannot able to change always the tool one after another. So that is the main advantages of a non-traditional machining process where there is no physical tool is present. But some cases the tool is present, the physical tool is present, but that should not be harder than the given workpiece. Next, in NTM, the tool need not be harder than your given workpiece, as I have already discussed. Example, in case of EDM, we are using the tool material as a copper to machine the hardened steel. Then second last characteristics is, NTM process do not necessarily use mechanical energy to provide the metal removal rate. The only mechanical energy is not required. We can use various energy domain for machining in non-traditional machining process. So that we can discuss when we are going to classify the non-traditional machining process basing upon the energy domain. So these are the classification of the non-traditional machining process basing upon various energy sources. If we discuss about the mechanical process, in mechanical process, what are the various non-traditional machining processes are there? One is abrasive jet machining, ultrasonic machining, water jet machining, abrasive water jet machining. If we go to the second energy domain, that is electrochemical machining, here there are a lot of classification of the machining process which is coming under the energy domain, which is electrochemical. Then last one in electrothermal process, where it is the combination of electricity as well as thermal energy in order to remove the metal removal rate in the following process. The last one is chemical process. Here we are using only the chemical energy domain where we can remove the excess material from a given workpiece. The example are in chemical machining. Second one is chemical milling. Last one is photochemical milling. Next, now why we require non-traditional machining process? There are various features of a non-traditional machining process exist. Number one, extremely hard and brittle material can easily be machined by using non-conventional machining process, which is totally impossible in case of your conventional machining process. Second one is, if the size of that particular component is very complex in nature or in critical shape or intricate shape, then we can use the non-traditional machining process. So there are some few examples are there. Suppose I want to do a square hole of 15 mm into 15 mm with the depth of 30 mm, which may not be possible in case of conventional machining process, but it can easily be machined by using a non-conventional machining process. Last example is deep hole with a small hole diameter 1.5 mm hole with an ID of 20 mm. It cannot be possible in case of your conventional machining process, but it can be possible in using non-conventional machining process. So these are the some of the examples where it is highly required to choose a non-conventional machining process other than a conventional machining process. Next, moving to our topic, abrasive jet machining. So initially, the students should know what do you mean by abrasive. Abrasive means these are some of the minerals which having some cutting edges which is required for machining. Take an example. Abrasive jet machining process comes from conventional sand blasting process. What do you mean by conventional sand blasting process? I am having one. This is sandpaper where the abrasive particles are there. When I will rub this sandpaper upon a surface of a workpiece, then I can see some of the material can be removed by the sliding action of this abrasive particle which is present in the sandpaper in order to do the metal removal rate. So from that concept, the abrasive jet machining come into picture. So where abrasive are nothing but these are the minerals having some cutting edges Again, what do you mean by jet? Jet is nothing stream of flow of abrasive particles. Machining again, machining means removing of excess material from a given workpiece. So in abrasive jet machining process, same thing we are doing. We are impinging the abrasive particle into a given workpiece with a standard distance of 0.5 to 15 mm. But then what do you mean by standard distance? Standard distance is nothing but the distance between the nozzle tip to the given workpiece. That is nothing but the standard distance. So during the standard distance, the abrasive particle having a very higher velocity rate, abrasive jet, that is around 150 to 300 meter per second, that will impinge on a given workpiece, where due to the impact or due to the impingement of the abrasive particle on the given workpiece, the metal removal takes place. So this is the basic principle of the abrasive machining process. Let's go into the schematic diagram of abrasive jet machining. So before going to that, what are the equipment required for the abrasive jet machining? That to be clear. We require one air compressor in order to require the air pressure, or which will develop the air pressure. Second, we require the pressure control valve, which will regulate the pressure of air which is required for the machining process. Second, we require a dryer, which is also called as dehumidifier. So what is the function of dehumidifier? It will evaporate or it will absorb the moisture whatever is present in the compressed air. Again, why it is required? It is required in order that if some of the moisture content will be gathered in the mixing chamber, then the powder particle whatever we are using as abrasive particles in the ASM, that will be bonding will take place. That will accumulate at a particular place. So in order that we have to remove the moisture from the air, compressed air, in order to get the free from the moisture. Then after that we require the filter. Why we require filter? Because in case of the filter, if some of the foreign particles will be present on the air, that will again it will interact or it will mix up with the abrasive particle. If with the same foreign particle and your abrasive powder, it will enter into the nozzle, may due to the presence of the foreign particle, the nozzle will block, or sometimes if the foreign particle size is very much small as compared to your abrasive particle, then in the workpiece the impingement of the or indentation of the abrasive particle will be gathered at a particular place. So in order to that, we have to remove the impurities which is present in your air, compressed air. After passing the air from the filter, it will directly go to the mixing chamber, where the abrasive from the abrasive feeder, abrasive particle which is in the form of powder and your air mix up with a particular concentration ratio of 30%, where we are using an electromagnetic shaker in order to mix up with the abrasive powder with your compressed air. After that, from the mixing chamber, air will go through the nozzle, where nozzle is made up of very hardened material, that is tungsten carbide and sapphire. Through this nozzle, the abrasive powder will start to flow, and then it will impinge on the given workpiece, where due to the impingement of your abrasive particle, the metal removal takes place.